Hello everyone. So I am back to talk about a little project I've been doing in Factorio. So this is a game that is kind of like Minecraft if you were to take automation and inject it into that and then keep it in a 2D plane. So it's more about the crafting and doesn't have as much in the way of exploring and building interesting structures. It's more about how to organize and how to craft. So with that, there are some real basic concepts that you start off with. So this character here, this little guy, he landed on this alien planet, crash landed, and he wants to get back home. So in order to do that, he wants to build a spaceship that'll take him there. To get a spaceship though, he needs to build all the parts that lead into a spaceship. You're going to use an inventory where you can pick things up and move items around. As well, you're going to be mining for pretty much any resource that you need to use. That includes trees and stones and other minerals like ore. Now let me try and explain the basic concepts of Factorio's automation. You start off with nothing but the guy. There's no official name, but that's boring. So I'm going to name him Carl. Carl can use a pickaxe and get some basic material like ore. He's slow, but he gets the job done. In order to use the ore, he needs to smelt it into something useful. To do that, Carl puts the ore into a furnace. Once it processes, we now have iron plates, one of the most used items in all of Factorio. However, Carl is too slow, and he has better things to do. So instead of mining everything himself, he builds a drill to do it for him. Bye Carl, I'm taking over. Now we need to turn those plates into something more specific. As an example, let's use iron gear wheels. I make an assembly machine that processes iron plates into gear wheels. However, iron isn't all we need to use in Factorio. Let's add copper into the mix. We can do the same thing to smelt copper into copper plates, then use those copper plates to make copper wire. Now this is where the fun begins. We start combining multiple items together. Let's use copper wire and iron plates and make circuit boards. We aren't just limited to combining two items though, so let's make some inserters, the grabby hands of Factorio. To do that, we need to combine circuit boards, iron gear wheels, and iron plates together in an assembly machine. We get that going, but we still need to make more things. So at the same time, we also start making conveyor belts using iron plates and iron gear wheels. Think that is all? Not quite, because all of these manufacturing points need fuel. At the start, that's going to be something you can burn like coal. So we drill for coal and start putting it into the furnaces. Yet most of the work is going to be done by electricity. So in addition to powering the furnaces, the coal will be used to power a steam power generator and deliver electricity via power lines. And then don't forget to connect every single thing that needs power to that power generator. So to recap, to make an inserter we need to drill for iron ore, smelt the iron ore into iron plates after we get coal to the furnaces, power an assembly machine, drill for copper ore, smelt the copper ore into copper plates, assemble copper plates into copper wire, use iron plates and copper wire to assemble a circuit board, use iron plates to make gear wheels, then combine the gear wheels, circuit boards, and iron plates to make an inserter. This is the foundation of all items in Factorio, and everything is made in some sort of combination of other items and manufacturing points. I could go into more, but there are a lot of items, and it's mostly a variation on this process. Some real basic tools that are at your disposal. So these little guys are called inserters, and they act to just move something from one thing to another thing. That could be moving it from the ground to another spot in the ground. It could be from a box into this thing here, which is a manufacturing or assembling machine. It can be whatever the case is, it just moves something from one spot to another. For this assembling machine, what I'm going to do is I'm just going to set it up to manufacture iron gear wheels, and it requires iron plate. It requires two of them actually. So I pick this up, it's going to say it needs 2 iron plates. So all I have to do is put in enough and it will start manufacturing. You can do it directly by just inserting into the machine like this, and it will work, but what's far more efficient is to feed it in the way of something else. So what I'm going to do is I'm going to put these iron plates in this box, and then this inserter here will then feed this when it's out of plates itself. So you can see how it's feeding it, and it's then using the plates that have been added to then manufacture the iron gear wheel. everything needs power. So I have these power lines that you can see they go across the screen. Making sure that everything has power is a little tricky at times, but I'm also going to exploit that for some of the things that I'm doing with my factory. Now, in addition to inserters and manufacturing locations, inventory management is kind of a big deal for this game, and honestly it works better when you're using different storage techniques and devices rather than using everything on your own person, carrying things around and then picking them up, dropping them off, something more akin to what Minecraft does. In order to do that though, we want to use conveyor belts. So conveyor belts are an essential tool in Factorio, and what they do is they just carry things around from one spot to another. Very simple. Then with some smart design, you can use inserters to pick up everything, pick up some things, move stuff into machines, move stuff into boxes, whatever you want to do. Some inserters are more picky. So like this is just a basic inserter, but there's this thing called a filter inserter. So then if you were to use that, what that means is that it is only going to pick up the items that you allow it to pick up, or conversely, if you want to ignore some things, you can blacklist those items. This video is going to be pretty information heavy, so I want to outline what my goals are and how I achieved it. So to start off, I wanted to create a way to auto-sort everything I mine and manufacture. I found it incredibly tedious to manage my inventory, and I ran into a ton of inefficiencies when I tried a more simple, criteria-driven storage thing using filter inserters, and they would just put things in boxes, and I just didn't like how laborious it was after that initial simple part of it. Next thing I wanted to do was make it expandable. I wanted to not have to rebuild everything whenever I changed a routing or needed some part of the factory to grab some of the items that I had already sorted, and making it more expandable would solve that. Next, I wanted to be able to supply my manufacturing automatically. Just like storing stuff is tedious, pulling things out of storage to use is also tedious. So I wanted to solve that. I want to be able to activate and deactivate parts. There's going to be times when some items I have plenty of and some items I don't have enough of, but they're drawing from the same original material, and I wanted to be able to manage it a bit better. And then lastly, I just wanted to do something cool. This was a personal challenge, and I wanted to make something really sophisticated and complex, but still logical. The brainchild of this entire factory stemmed from the realization that I could use a splitter to filter items instead of relying on filter inserters. Inserters are great, but they require power, and they can only pick up a limited number of items at a time. Splitters require no power and are only limited by the conveyor belt speed. I started sketching out some ideas on how I might be able to do this. In the sketch, you can see that my plan was to make vertical conveyor belts carrying the unsorted items that would then be filtered by splitters to be stored horizontally. This is very close to the end result that I'm using, but I'll show that in just a minute. I also want to note that the items can be transferred to other conveyor belts at T-junctions. I use this to consolidate and reduce complexity quite a bit, but there's a bit of a balance between something that's fast and complex versus something that's slow but simple. A good example of trying to balance this is the way I unload into my sorting area. Trains in Factorio are the fastest way to carry material over long distances, but they must be loaded and unloaded. The faster I can do that, the faster the train can pick up more material. However, we have to balance complexity with speed. My sketch for a train unloader was to use 12 inserters to unload, but consolidate them into 6 conveyor belts for sorting. Let's take a look at the final result, and you can see how all this works in practice. Right now, there's a train coming in. You can see how it's getting unloaded, and how this mimics what my sketch was for how this should work. The inserters first put it into a storage box, that way, in case there's any leftovers that were stopped because the conveyor belt was full, they can then continue to work after the train has already left and is on to its next delivery. And then you can see all of these conveyor belts are moving up vertically, and they're getting combined. So you can see each one goes from 2 to 1, and you can see how that then gets split out. And then we're going to look at all the different filtrations that's happening. So you have coal is filtered first, and then it checks to see if it's coal. If it's not coal, it moves on. Goes to pipes, not pipes, moves on. Copper plates, it's not that, move on. Steel beams, plastic, I forget what that is. The copper wires, all of these things that get split out and sorted. Whenever they get sorted, what happens is they run the conveyor belt here, get combined with the other vertical to make it a horizontal. Then they move up, over, until they're all combined into this horizontal line that then gets to be picked up and stored. So you can see in this case, the gears are getting picked up and loaded into different boxes that then consolidate. Continually, there's an inserter that'll take anything that's stored in the right box, it'll move it to the left, so that everything gets loaded as much as possible into the leftmost box. The leftmost box is going to be the one that loads then the conveyor belt for all the items that are being called back into the factory. To show how this works a little bit more altogether, I'm just going to zoom out a bit. And you can see just how many there were here that get sorted. Each item has its own horizontal line that goes along with the vertical line that just goes all the way up to the top. Because this is a closed loop system, I don't have to worry about something getting stuck at the end because everything should be filtered by the time it gets to the end. You'll note also that there's plenty of space above this, so if I want to expand this, I can. I can just get rid of some of these rocks. I can just keep on going all the way up here continuously if I want. I could also curve it if I want to in order to make sure that I have enough space. Another important concept to understand for this whole project is the use of green and red wires to transmit information. You see here are 11 connection points. I can connect these with either green or red wires and they will work independently of each other. So if I connect information green A that constantly originates from the top row and information green B that constantly originates from the bottom row, all four of the top row will show green A and all four of the bottom row will show green B because they touch each other with the same type of wire. If I connect a green wire to the middle row from the bottom, green B will automatically be transmitted to all of the connection points in the middle that touch green wires. Now, if I connect a green wire from the middle row to the top row, what happens is that all information of all green wires is instantly transmitted. Now, instead of green A or green B in the different rows, green A and green B are instantaneously combined, shown here as green AB. Now if I connect information red C originating from the top row and red D originating from the bottom row, they only transmit where red wires are connected. Even though there is a green wire connecting the rows, since red and green act independently, there is no crossover. It is as if the red and green wires do not know the other exists. Next, if I disconnect the green wire's connection to the top row, we are back to being limited to only green A on the top and green B on the bottom because that is where the signal originates from. This is important to note because there's no memory. It is not like mixing water in a pipe where once dirty water touches clean water, it all becomes dirty. The signal is instantaneous and only exists when there is something originating from it. Let's exploit this and add in some math. Some of the tools available in Factorio means that I can modify a signal with a specific input and output. Quite simply, I can take a number in, change the number, then output the modified number. By exploiting alternating green and red wires, I can modify a signal multiple times in a strictly controlled way if I use green input and red output, along with red input and green output. In this example, I am starting with a green 0 that is input into a math machine that adds 1, then outputs the modified number that is now a 1 instead of a 0. This goes to a connection point that can use that information, but then is connected to another math machine that inputs the red 1, adds another 1, then outputs a green 2 that goes to another connection point and connects to another math machine's input. This cycle can repeat as many times as needed. Because green and red act independently of each other, we can have two separate numbers on the same connection points so long as the greens and the reds are connected with inputs and outputs with the math machine in between. This means that we can reuse connection points and have multiple pieces of information that are very similar but can be used for different reasons. In this diagram, I want to draw your attention to one bit of difference in the bottom right, which is that the math used an equal sign. Technically, this is not exactly an equal, but it sort of is. What I'm doing here is using one of the math machines as a memory cell. Let me explain. Since all the information on these wires is transmitted instantaneously and continuously, there's a simple way to maintain a value if you exploit an infinite loop. Normally, an infinite loop would be bad, but in this case, it's necessary. Let's use the value of 6. All we have to do to maintain a 6 is to add 0. 6 plus 0 is 6. So if we have math that is constantly running, calculating every CPU cycle, 6 plus 0 will equal 6, which is modified again by adding 0. So it is still 6, so it adds 0 again, over and over and over again, and the value stays the same. This is crucial for my whole system to work because I need to have certain values maintained on the information network that will then be modified by the physical actions in Factorio. Next, I need to explain how this is used in a practical sense. I use an inventory system to supply my factory with the parts needed to manufacture more parts. This diagram is my basic setup, though you'll see that there's a little more later on. On the left is going to be my manufacturing building. In the middle will be a short-term storage location. On the right is the long-term storage location. Keep in mind that there will be physical activity happening that influences these numbers that will update this information on the network, but it is important that the network is controlling the physical activity. The first step here is for the manufacturing building to grab an item it needs. The act of picking up an item triggers a signal pulse of information that is a quantity of 1 in the type of the item it picks up. This quantity of 1 is transmitted as a +1, and I run it through a math machine that multiplies the number by -1, changing the input from plus to minus. This is then stored as a value in the memory cell dedicated to the manufacturing building. I have it set up so that there is a target number of inventory where if the number goes below that, I turn on a process that will then try to resupply the number back to the target. In this example, since the target for the manufacturing building is 0, if it goes to -1, like in this case, it will enable inserters to take a resource from the short-term storage to refill it back to 0. The act of pulling a resource from the short-term storage will use the same process to report that the short-term storage, where the target number is 200, is now below the target. Then the same process happens, but this time it is the short-term storage pulling a resource from the long-term storage. Now that all the calls have come in, we have to wait for the physical world to catch up to the information world. Once that happens and the manufacturing building receives the resource, it returns the value to 0 and turns off the inserters because they only turn on when the value is below the target. In the same way, once the short-term storage is satisfied, the reported number goes up and the inserters turn off because the target is reached. This process can repeat so long as the long-term storage has enough resources. In my setup, the long-term storage is refilled in a different way, either by receiving manufactured parts or raw material, and there's no target for it. If it reaches a value of 0 or less, that just means that more of that resource is needed. Now let's take a look at this in the game. I'm going to call this a manufacturing point, and let me run you through the different parts. There's a bit of noise here, so let me get rid of some of the things that are not relevant. The first thing to note is that these are the manufacturing buildings. This is where all the items are inserted so that they can make what we want them to make. They are fed by inserters below and they output with these inserters above. The output conveyor belt will work its way to the long-term storage, but more on that in a bit. The manufacturing buildings and these inserters are all a simple on or off system using a power switch, so their operation is pretty straightforward. The inserters grab from this conveyor belt, which acts like an immediate cache of always available items. This cache is fed by these boxes, which each contain one of the different types of items used by the manufacturing point. These 3 inserters are controlled by the circuit network and replenish the cache belt as soon as one of the items is picked up. This works because the manufacturing building inserters are hooked up to this red wire and send a single pulse of information to tell the circuit network what item they just picked up. That information is converted by this math machine to a negative number and then stored in these different memory cells. There are 3 memory cells here, each relating to one of the items used by the manufacturing point and stored in each of these boxes. To demonstrate, let's watch what happens when this gear wheel gets picked up. First, there must be a need for a gear wheel in the manufacturing building when it goes past an inserter. Once there is, then it gets picked up and put into the building, and a pulse signal is sent by the inserter to say it is holding 1 gear wheel. This signal goes into the math machine, the value is converted to negative, and it is then sent and stored in the gear wheel memory cell here. The memory cell now shows a gear wheel value below 0. Now since the condition for the inserter connected to the gear wheel box is to activate when the circuit value of the gear wheels is less than 0, it turns on and picks up a gear wheel from the box. When it does this, it sends a pulse signal to say it is holding 1 gear wheel. This signal goes in 2 directions using red and green wires. The signal on the red wire goes back to the gear wheel memory cell. Since there's no negative conversion, a value of +1 is added to the memory cell and the value becomes 0. This then means that the inserter's condition to turn on is no longer met because the value is not less than 0, so it turns off. At the same time, the signal on the green wire goes to this math machine where the value is converted to negative. Because red and green are completely separate, this is fine because they will not cross-contaminate the values. That signal will trigger another similar process that I'll go over in a minute that causes a gear wheel to be added to this conveyor belt to the right. The signal and the activation of the inserters all happen in the span of about 3 frames of my 60 frame per second video, which translates to about 0.05 seconds. Because all the signaling happens almost instantaneously, you should see inserters reacting just slightly after the initial signal is sent. You can also see whenever any action happens on the circuit network because they flash a light to indicate activity. The last step for the manufacturing point is to refill the item boxes. These inserters are simple filter inserters, so they will pick up any of the items that they are instructed to pick up as soon as they come into range. All of this maps to the process I talked about earlier, but now you can see how it functions within Factorio. Now that we know how to fill up our long-term storage and manufacture items, we need to know how to get material from the storage to the manufacturing point. To do this, we need to do 3 things: pick the right items to send, deliver them, and do it efficiently. We've already gone over the basic idea of how an item can be ordered and fulfilled with the manufacturing point, and the same concept applies to pulling items out of the long-term storage. I have a bank of memory cells that are used at the long-term storage that trigger the inserters to pull items from the LTS and get them to a train that will go to the manufacturing zone. Because this is controlled by the circuit network, only items that are needed get added to the outgoing train delivery, so I don't have to worry about oversupplying the manufacturing points. They get what they need, nothing more and nothing less. Delivery takes place at first by train, but then it needs to be distributed. Just like with the manufacturing point, there are different boxes that will serve as buffers to make sure that the supply is consistent for all the manufacturing points. In order to keep it efficient and consistent, we need to appreciate that the more time it takes to deliver material, the higher the buffer needs to be. This graph is not a perfect example, but it roughly demonstrates how this relationship works. In my scenario, I have 5 buffers. You've already seen 3 of these: the conveyor belt cache, the manufacturing point storage, and the long-term storage. But to be more efficient, I also added another short-term storage and a medium-term storage. Beyond simply using buffers, we also need to sort what the long-term storage delivers in a way that distributes all the items equitably. Let's take a look at the medium-term storage to see how that is accomplished. The first thing to note is that the train unloads in basically the same way as with the long-term storage, but rather than using splitters, which take up a lot of space, everything is sorted using inserters that fill up the medium-term storage boxes. This is accomplished by putting everything from the train onto a looping conveyor belt. It is looping because every item has a destination, so if something is missed because an inserter is overwhelmed, it will pick it up on the next pass. The medium-term storage then distributes items to the different short-term storage B points. These are all linked to a single manufacturing point and work exactly the same as the way that the manufacturing point's short-term storage works. But because it is closer to the medium-term storage, it can pick up items that it needs on a looping conveyor belt. Now, as long as short-term storage B has enough items, it will work exactly the same as the manufacturing point's call and receive system and connects to those manufacturing points by a single conveyor belt. Now that you know how it works, let's take a look at the whole thing. My rough map I sketched out looks like this, and I come pretty close to that in reality. Starting with the medium-term storage, you can see how it is being fed by the looping conveyor belt. Then it will send material on demand to one of the various short-term storage B locations. Then you can see how the conveyor belt flows down from them. Thanks to the way the space is arranged, they offset up and to the left, so the manufacturing points shift diagonally to make sure that there is enough space. Every single item that is coming down because the manufacturing point called them, and every one of the items they output will go back to the long-term storage, ready to be used for further manufacturing. This then closes the loop and achieves my goal of creating a factory that runs itself. But I have one more goal to achieve, which is to be able to turn things on and off. To accomplish this, I use a fairly simple tool in the circuit network playbook. Each manufacturing building is the basis of all material being supplied because it triggers the start of the chain of orders to be fulfilled. Thus, if you turn off the manufacturing buildings, then everything along the chain will stop as well. So what I use is a conditional power switch that only connects the power if a condition is met. To change whether or not the condition is met, I use something called a constant combinator. In this scenario, the condition for the power switch is that the number of inserters on a separate network is greater than 0. When I add an inserter icon to the constant combinator, it will continuously transmit the value of that inserter, and so it meets the condition to power the manufacturing buildings. If I take it away from the constant combinator, the condition is no longer met, and it will turn off. This can apply to any of the items I manufacture, and it can all be controlled by this one constant combinator that I have centrally located. If I want everything to be turned off, I simply turn off the constant combinator, and now none of the conditions are met. What is really great about this is that I can turn everything off, then wait for all the orders to be fulfilled, and check to make sure that all the buffer points are at the levels they're supposed to be at. If they're not, that would indicate a problem, and then I could start to troubleshoot. With this, my goal is accomplished, and I have the closed-loop manufacturing factory I envisioned. There are still some issues, mostly that the total ability to supply my manufacturing points are limited by the number of items that can be transported by a conveyor belt, but by turning off some manufacturing points I can limit the total load on the system. I also made a separate system add-on to accommodate the massive need for iron plates, as well as a separate drop-off spot for my research area, but those largely follow the same logic as the rest of the factory. I had a lot of fun figuring out how to do this and then putting it together in this video, even if it took way more time than I expected. I'm sure there are a lot of other clever ways to do this same thing, but I'm pretty happy with how it turned out. If you made it this far into the video, I hope you enjoyed it. Life can get in the way, but I hope to put out more videos in the future on whatever gaming topic my eclectic tastes drive me towards. Thank you for watching.